Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms from the very basic stuff to the intermediate stuff and hopefully to the very advanced stuff. I love saying stuff. Stuff. It is due to my lack of vocabulary. Well, in this video, I'm not actually going to be going over the notebooks, not particularly. I'm just going to talk about, or rather try to, try to estimate what I'm doing, estimate the time it will take for what I'm doing right now on Google Colab. So recently, or rather right now, about a few hours ago, I subscribed for Google Colab Pro Plus so that I can run 4 notebooks without stopping 24/7 for as long as it would take, for as long as each one would take, but I'm running them simultaneously. And it was about what, $50, 50 USD or 60 USD. So, and what I'm doing there is I am I have right now I have so here's what I'm doing. I used to have 7 distributions. This looks like the color is so not pleasant. I used to have 7 distributions. 7 distri. That's a D. But I also recently I also added a left skewed distribution. Skewed, which looks like this. No, yeah, which looks like that. Because everything that I've every distribution that I've had either looks like this, or this, or this, normal, log normal, uniform, like that, or something like even steeper like this. Yeah, you get what I mean. So there were 7 of them. I didn't have anything that looked, anything that even looked remotely left skewed. So I added that. So now I have 8 distributions. But because until now I've sampled all the utility values and the constraint values from one given distribution every time, I didn't think it painted the right picture. So what I'm doing right now is I'm sampling from all possible kinds of distributions each. So for one instance, it could be that the utility values are sampled from this one, log normal, and the constraint values are sampled from uniform. And then maybe in some other run, the constraint values are sampled from the normal distribution. And now that I have 8 distributions in total, 80, oh, that was bad. That does not look like an S. 8 distries, and then all the number of all products are 8 by 8, which is 64. I know I could just exclude the ones where the same distribution is used for these 2 sets of values, because I've done that so many times, and now I have also the pictures, the plots, the peak plateau plot, but I don't have well, since the notebooks that I'm running will allow me, no, rather, will save all the data in terms of what is it? I forgot. My bad. The average of some utility values for the top 10%, top 10p, the head, or the top entity, the tail, the bottom entity, and by having these values per max constraint percentage will allow me to calculate the plateau level, the peak level, the maximum ever also, and it will allow me to draw and recreate the peak plateau plot whenever I want, because now and up until now I didn't save any of them, so if I wanted some other data I had to rerun it. So to save myself the trouble of rerunning again, I'm actually doing all the 64 products of 8, from the 8 distributions. Now, having said that, this is where the problem, or rather it's not actually a problem, or it could be a problem, but let's be the judge of that. So it takes about 105 to 110 minutes per notebook, per product, on my Mac, and there are 64 of them, and which means that in total 110, slightly less than 110, but I would just say 110. 110 times 64 is that 7040. Really? Okay. Minutes. So this is minutes, and in hours that's 117 hours. So in days, that's 4.8 days, so 5 days of me constantly running the notebooks. Yeah. So, and I moved on. So since I subscribed for the Google Pro Plus, here is the disappointing bit. I thought it'd be faster, but then again, I did not optimize the code to utilize the GPU or any sort of faster processing or computing. So even on Pro Plus, the only benefit that I get is that the notebooks won't stop running when I close the browser. So I'll leave them on. The notebooks will keep running until they're done. However, even here I find that everything is kind of slow, because what took me 440 seconds would take around 21 minutes, let's say. 21 minutes, 440 seconds. So 440, go away. 440 divided by 60 is 7.33333. So 21 minutes. So it means that all of this would be 3 times slower, would take 3 times as much, right? Yeah. So it's 330 minutes per notebook, per distribution product. And when I say a distribution product, I mean something like normal for utility values and Pareto for constraint values, or normal for utility value, or normal for constraint values. So there are 64 of them, like uniform and log normal. Like log normal and variable. So there are 64 of them, and each one would take. It would usually take 110 minutes on my MacBook Pro M3. However, on Google Colab, it is estimated that it would take around that. What was it? 21, 7.3333. So divide up by this. So about 2.86 times longer. So let's just say 3, to be safe. So 330 minutes. And there are 64 of them. Which means that it would take that amount, 21,120 minutes, which is what? No, that's not it. 60. 352 hours, which is 14 days. However, I have 4 notebooks, so I can divide this by 4. So 3.6666666666 days. 4 days. Okay, maybe. Yeah. So at most 4 days if the Colab notebooks don't stop. If the run times don't stop. I hope they don't. I paid like $50 for this. $50 or $60 for this. Yeah. That was my Siri. I don't know why she responded. I didn't call her. So 3.6 days. 3.7 days. Okay. And yeah. And how many and as a result, I will have per product, so that is 64 products, I will have 3 peak plateau plots. So that is 192. Is that right? I don't know. It is probably right. 192 plots. No, well, 192 plots that could be generated because I would have 192 JSON files. And at this moment, at this moment, the computation for all the 4 notebooks are doing the first bit of the computation, which is doing their things for 10 items. So I have 4 notebooks, 4 Colab notebooks running right now, 4 runtimes, doing 16 distribution products, and they're still doing the first bit, and it will only get longer from here on out. So it's going to be a long wait. you know. Well, I hope it's worth it. In the meantime, I could probably find a new way, well, improve the way I evolve. Yeah, so that when the maximum constraint percentage goes up, I still find ways to introduce procreation somehow. Well, I can think of one or two ways, but I still have to try. I still have to try those out. Yeah. I mean, and remember, the entire purpose of all this shenanigans, all this is, what am I doing? All this is so that if I am to draw a peak plateau plot, no, actually, yeah, well, it's not the only purpose. In terms of peak plateau plot, I want the plot to go something like this, and well, I wanted to go something like this, and where, no, what am I doing? Where this is the total utility value. I want the plot to touch or nearly touch the total utility value when the maximum constraint percentage is at 100%, given like 500 generations. Because now I find that 500 generations is kind of plenty. Yeah. Maybe it's not, but so far it looks like it's plenty. Or maybe I need more. I need a bigger population. But then again, I think 1,000 entities to start with in the initial population is, well, why can I not draw a star? Is also plenty. And that's the peak plateau plot. That's the PPP. And all this was for me to find a way so that when given a maximum constraint, the summed utility plot will just peak and plateau. Will probably peak and plateau. So there will be a dip. There will be a dip. So minimize the dip, or get rid of the dip. That's what I'm trying to do. But since well, so I wanted to study about the dip size, or the average dip percentage, and see how it relates to how it's related to maximum constraint percentage. And here we are now, something a lot more complicated. I might have chewed off more than I could, well, bit off more than I could chew, rather. So that's the whole plot right now. So to minimize the dip, or maybe have the plateau level slowly rising, so that, well, if something is rising, it's not exactly a plateau. So again, control dips, control dip size, or control dip percentage, or rather and maybe in the end eliminate. Eliminate is too strong a word. Fine, minimize. But that also entails, kind of means that I would be getting rid of the plateaus as well, because then I want the sum utility plots to kind of keep increasing at a smaller, with a smaller slope, less steep of a slope, but still keep on increasing as the generations go on. I know it will never be the same when compared to generation 0 to generation maybe 100, or maybe generation 50 or 60, because that's when this steep climb happens. But I want the entities to keep improving. Maybe that's too much, but so that when this is the best possible answer, and since this is the average of top 10% entities, I would like it to be somewhere there, like as close as I can get to the best possible answer. It will never touch, by the way. If it touches, then it'll be just for a brief moment, like for one generation or two, and then it'll just fall back down, and then just keep rising. It will never touch. Well, it will never touch for an extended period of time. Extended, for more than 10 generations in a row. Maybe it can, but it's not likely. So that's what this is all about. And to do this, I need to find a better evolution scheme. I need to find the right mix, or the right method of procreate. It could be a new procreate function, or it could be a change in how I implement one or two or more procreate functions. Or it could just be adjusting the mutation rate as the generations go on. But I think that's a bit cheating. I don't think I'll change the mutation rate. I mean, granted, in the future the mutation rate could just fluctuate from like 0.01 or 1% to 0.03 or 0.05. 0.03. So that could happen, but apart from that, I don't think I want to change the mutation rate. Yeah. Okay. Well, that's about it for this video. I will try ranting in another video. So, thanks for watching. Bye bye.